For our very last learning intention of this topic, we're going to be learning how to graph functions as well as find its derivative on a graphics calculator. So there's one of two ways that we can do this. The first one is by using the graph mode. So firstly, we will just put into y1 our function or the original function that we are after. And then in y2, we need to follow this step sequence here. So that is we select option, followed by calc, and then hitting ddx. And this should bring up something that looks a little bit like this. Of course, because we've already written our function into y1, I'm going to hit this y here within the brackets, followed by the 1, so that the calculator knows that I'm finding the derivative of this function in y1. Next, for my x, I'm going to have that also equal to x. The reason being is that I actually want to graph the derivative function rather than just finding a specific value. So once I've put that into my calculator, I can now select draw and it will come up with my two functions here. Now we know that this function makes sense because here is my x2, and we know that if my function is decreasing, then my derivative values must be negative. So we can see that that's happening there. And as my function is increasing, then my derivative values in red should be positive. Okay, so we know that this would be the correct derivative function to my original function in blue. Now, if we wanted to find the derivative of our function at a certain point, we can select gsolve, followed by ycalc. Now we select ycalc because of course we want to know what my function is at a particular point. So in this case here, I just wanted to find out what was the value of my function, or my derivative function even, when x is equal to 1. So this tells me here that when my derivative function is equal to 1, its slope is 2. So I know for both my function as well as my derivative function, the rate of change at 1 is 2. And of course, we can use similar steps as well when we use just the normal calculator mode. So this goes into our second way that we can find derivatives. So what we do is we go into our normal calculator mode and we do the same process before, where we select option, calc, and then ddx. In this case, we don't have a value that's in our y1, so we don't have a function that we're already working with. So you'll need to actually input the function that we're interested in. So for this example, I put in sine of x. And then as it's no longer the graphing calculator mode or the graphing mode, we now actually have to put in when x is a specific value. I can no longer do x equal to x. As nice as it would be for it to actually spit out the derivative function for us, it would only just give us some random number, and I'm not sure at what point it would have calculated my x value to be. So in this case, we can only use this run matrix mode to find the derivative at a specific point. So that's all of our different ways that we can calculate the derivative using our graphics calculators. And I'll show you a few examples of where we might actually use this rather than calculating it by hand.
We're going to be looking at the last two examples of our calculus topic. At this stage, you've been learning to find derivatives of functions using the power rule or first principles. This could be functions involving polynomials or square roots as well as fractions. At this stage, you have not quite found out how to find the derivative of trigonometric functions. And as you can see from our two examples here, it is asking you to find the derivative of cosine of x as well as sine of x. So instead, we are going to be using a graphics calculator. For our first question, we are asked to find the derivative of cosine of x at x equal to 0. I'm going to be using the graphing mode to show you how to find this. So in y1, I'm going to input cosine of x. And in y2, I'm going to select option, followed by calc, and then d dx. As I've already imported my function that I want to find the derivative of in y1, I'm going to hit f1 for y, and then followed by my 1 here. And remember, I'm trying to find the derivative function rather than my derivative at a certain point. So I'm going to be putting in x equal to x. Once I've hit execute and I've got both of the functions I want to calculate, I'm going to hit select draw. And in blue, we have our cosine function, and in red, we've got our derivative function. Now, before I show you how to calculate the derivative at this particular point of 0, I just want us to have a look at my cosine of x function first. Now, I can see the actual value of cosine of x at x equal to 0 is 1. However, if we are looking at the tangent of my line at x equal to 1, then we can see that the gradient should be equal to 0, as this is a local maximum at this point. We also know that the gradient of our tangent line is our derivative, which means our derivative at this point here should also be equal to 0. And we also know this as our stationary points are also equal to 0. I can see my derivative function in red at x equal to 0 appears to be the value of 0. But I want to double check just to make sure this is correct. So if I select gsolve here and go over to the ycalc, making sure that I'm selecting the line for my derivative function here, I'm going to select execute, and then making sure that I set it so that I'm finding my y value when x is equal to 0. And I can see here that when x is equal to 0, my y is also equal to 0. And as I said, this definitely makes sense, as the gradient line, or the tangent of my line here, should have a 0 gradient. So there we go. We can now say that the derivative of my cosine of x at x equal to 0 is, in fact, 0. For our second example, I want to show you this using our normal calculator mode. This is asking us to find the derivative of sine of x at x equal to 1. So I'm going to select option, calc, d dx, and in this case here, I now have to actually input my sine function. And because I can't just do x equal to x, I now have to select when x is equal to 1. Now I can select enter, and I can see that the derivative, or the slope of my sine function at x equal to 1 is 0.54. So f of 1 is equal to 0.54. And there you go, we've now found the derivative for both of our trigonometric functions.